The 2010 Chile earthquake had a magnitude of 8.8 and struck at 3:34 a.m. This was the result of the subduction of the Nazca Plate beneath the South American Plate. Many buildings were significantly damaged, including 400,000 homes. In the aftermath, there was an apparent slump in the electrical grid. Lots of areas were left without major services, such as water, electricity, and gas. Major life loss in an earthquake is caused by collapsing buildings, specifically falling debris. Alto Rio, a 15-story condominium, collapsed in the earthquake. The entire building overturned due to failure of the first-story wall. 60 people were trapped in the building, and 16 survived. The 23-story O'Higgins Tower experienced partial collapse at floors 10, 14, and 18. Evidence shows the collapse of both high-rise buildings were due to lack of continuous reinforcement. The earthquake caused failure in the Las Palmas tailing dam. The failure was due to liquefaction at the base level of the dam. When the underlying tailings get liquefied, the coverage lost its stability, causing flow failure. The upstream construction method was used as it was the cheapest option, consequently being most vulnerable to earthquakes. Flooding led to loss of properties and lives, toxic materials, contaminated rivers and soil, which resulted in environmental degradation. This promoted health risks as toxic materials could get into human bodies via contact, inhalation, or ingestion. It's vital for people to be able to safely find a zone where they can shelter until the end of the earthquake. The Estadio Nacional is the biggest stadium in Chile with a capacity of 48,000. We studied the stadium and the best ways to evacuate, noted several ways to decrease risk and speed up the process. These include removing a park on the exit, which will increase the width of the road from 15 to 27 meters. The number of turnstiles should be reduced to control crowd ingression. We can also increase width of gates to increase egression rates. Bigger exit signs with color contrasts along with light-up signs should be added. These small changes will help keep the fans in the stadium safe in case of an emergency. Certain actions could be taken in tackling earthquake problems. Some solutions would be to enforce detailed specifications for reinforcing steel to improve the integrity and ductility of concrete structures that will be subjected to seismic load. Structural design review, building inspection, and material tests should be frequently conducted on older buildings. Communities should be equipped with the right knowledge to face earthquakes in future, minimizing human and material loss. Finally, post-earthquake studies should be conducted and shared with the world to analyze important engineering aspects to prevent human-caused disasters.
Created using Powtoon.